Welcome, everyone. My name is David Schmidt. I am the CEO of LifeWave, and today I have the privilege of speaking to you about a new, affordable stem cell technology. And what's so exciting about this is that using a form of light therapy, we are going to be able to activate the endogenous stem cells already in the body and get them to perform like younger, healthier cells. So let's take a few minutes and talk about the background of this technology, how we did the development work, the clinical studies, and the actual real-world results that we're seeing every day. So first, we can address the problem. Problem, of course, is that as we age, the stem cells are going to age along with the rest of our body. Stem cells begin to slow down. This, of course, is especially noticeable by the time we get into our 60s. Stem cells will produce less growth factors, making them less effective at creating new cells and healing the body. And eventually, there are, in practical terms, no more stem cells left in the body. And anyone that's over the age of 75 or 80 knows that they don't heal very well. So what are some of the alternatives? Well, of course, people are looking at stem cell injections. They're still very, very expensive, so they're not available to everyone. There are risks associated with exogenous stem cell injections. A beneficial outcome is not always achieved, and very advanced treatments have yet to be approved. So the question that we began asking ourselves over 10 years ago now, when we began this research, is can we utilize the stem cells that are already in the body and get them to behave like younger, healthier cells? During this process, we have secured over 70 patents in the field of stem cell medicine and regenerative research, regenerative medicine. And in the early days of this research, we were very fortunate to develop a collaborative relationship with the National University of Ireland in Galway, and we conducted the work at the Regenerative Medicine Institute, funded by the Irish government through Scientific Foundation Ireland. One of the first technologies which I invented and then we later patented was a novel form of magnetic field therapy for activating the stem cells already in the body. In addition to standard in vitro work that we did, which demonstrated neurogenesis and neurite outgrowth, we later moved to animal models, one of them being a standard rabbit model in which we were looking to see whether or not we could obtain wound closure when we would induce a diabetic ulceration. So one of our tests included a standard control group, along with a group being treated with a magnetic field. What we would do is sacrifice the animals at day 7 and then look to assess what would be the difference between the control and the test. And what we found on our very first test was that utilizing magnetic field therapy produced a statistically significant increase in the rate of wound closure as compared to a control. So this told us that, yes, by activating the stem cells already in the body, we could get them to be more active and heal the wound more quickly. Now, of note here is that if you were to apply Matrigel, which is MSC stem cells in a collagen matrix to a wound, you would see the same rate of wound closure. So this was really the first indication that you do not have to necessarily inject stem cells to accelerate wound healing. You could use the stem cells already in the body. In our labs in San Diego, we work with planaria, which is a standard stem cell model. And when you cut off the head of a planaria, they will regenerate in about 17 days. So we'd like to see if we can accelerate that. In the very first test of this novel magnetic field therapy, we're able to regenerate the heads of the planaria in only 8 days. In more sophisticated versions of this technology, we're actually able to regenerate the heads of the planaria in less than 1 day. So remarkable efficacy. The problem, though, with this is that the technique is very expensive, can only be used by doctors. There's regulatory issues with it, and it's just simply not an affordable approach for consumers. So is there any way that we could apply what we learned from these tests and come up with something affordable for human beings? And how would this technology work? Well, we decided to look in the area of light therapy. I have been developing and inventing light therapy technologies for the past 20 years, and we had quite a bit of body of evidence to show that light therapy could potentially activate stem cells already in the body. This product and this device is a patch. It's activated by body heat. So it doesn't use a conventional power source. Doesn't use conventional electronics. It uses properties of natural organic materials. They're processed in a specific way to reflect specific wavelengths of light. So you could take the patch and let's say you apply it to the area where there's a wound or an injury. It's activated by body heat, and it begins to reflect wavelengths of light that stimulate the skin in the infrared and the visible spectra. Now, this is more properly known as photobiomodulation, and it's really the basis for phototherapy. It means that specific wavelengths of light can trigger very specific biochemical reactions in the body. We're all familiar with this already. We know that going out in the sun will create or cause the body to make more vitamin D. So this is the scientific basis for this photobiomodulation. And another way to think about it is that it's a form of low-level light therapy. Now, what we're going to do with this specific product is look to elevate the peptide GHK-Cu, or copper peptide. Now, what makes this such an interesting study is that copper peptide, which was discovered by Dr. Lauren Picard more than 45 years ago now, is that has a few very, very interesting features relative to the way the body will metabolize things like amino acids, functions on the heart, the brain, but also specifically, it's a very powerful gene modulator, and it can activate the stem cells, cause them to proliferate. So we want to look at elevating copper peptide as a means to improve stem cell activity. And instead of giving an injection of copper peptide, we're going to do this with light. Now, we performed about 8 clinical studies so far, and we were doing things like blood testing, urine testing, bioelectrical tests, and the studies are ongoing now. But the first test is that we want to simply know, can we see changes in the blood when applying light? And can we get an increase in copper peptide? So this was our initial pilot study, which we followed up with a larger 50-person study. Levels of copper peptide decrease over a period of time, much to the way stem cells decrease in their activity. They're relatively parallel. So we chose a population of people over the age of 60. They're wearing the patch over a period of 7 days, and we can see what happens that just within the first 24 hours, there is a statistically significant increase in copper peptide, and this continues on through day 7. So we showed that light therapy can elevate copper peptide. We're also able to do a metabolism study. And now this we did both in a pilot study with 10 people and a larger 50-person double-blind study. Again, we wanted an older population since they would have lower levels of copper peptide and lower stem cell activity. Patch was worn over a period of 7 days. And again, we saw a very significant change in the metabolism, an increase in the metabolism of amino acids, even in 7 days, an improvement in short-term memory, which is really remarkable. We also saw an improvement in blood pressure. Those individuals that had high blood pressure got reduced blood pressure. There was an improvement in heart rate variability, so the ratio of muscle contractions in the heart, an improvement in the very first 24 hours in the quality of sleep. People reported better feelings of energy during the day and even improvements in breathing. So it turns out that elevating copper peptide with light has very broad health benefits. Now, we also wanted to see what would the potential benefits be on the brain. Could we improve cognitive function by activating the stem cells through copper peptide? So again, we did a pilot study, and now we've done a 50-person double-blind study. And this was with 12 people over the age of 50. The patch, by the way, can be applied pretty much anywhere, but for the sake of convention in these studies, we've been applying them either behind the neck or below the belly button. Now, these results were obtained over a period of 6 weeks. Session 1 on the left is the baseline. Session 2 is at 3 weeks, and session 3 is at 6 weeks. And what we can see already in this individual that's 77, and we would expect, as you all know, that in someone over the age of 70, we're not going to see very much stem cell activity. So these results are remarkable. So we see a very dramatic shift, even after 3 weeks, in the coherence of brain waves. This was done, by the way, with a P3 system. And now here's a gentleman that's 67 years old, patch applied below the belly button. We begin to see a shift in brain coherence after 3 weeks, and then a very dramatic effect after 6 weeks. So this is all to say, why would someone get a benefit after 3 weeks, where some other people it might take longer? Of course, things like age, nutrition, a quality of sleep, supplementation, hydration, exercise, pre-existing health conditions, all of these things are going to play a role in the speed at which someone would see a result with this technology. But in this particular study, all 12 people saw statistically significant benefits as monitored through EEG. Now, what are the real world results with this? We've seen very, very dramatic effects. This was an individual in Italy who had open heart surgery in July of 2017. They first started using this light therapy patch in July of 2018. And you can see, even though they had had this scar for a year, we get a very dramatic reduction in the appearance of this scar in only 1 month. Here's another example. This was someone that had had surgery in August of 2020, so this was quite recently. And you can see after only 2 weeks, a very dramatic reduction in the appearance of the scar. Now, the patch can be applied right at the site of the injury, or it could be applied, again, behind the neck below the belly button. This is a systemic effect. And again, we see most people like to apply it locally. They feel it works better there. That may be psychological because our tests show otherwise. But in any case, you apply it and you get the result. This is from a distributor that we have in France whose son was involved in an accident just prior to a job interview. And just after 5 days, we see a remarkable improvement. Again, this is a remarkable story. This person was involved in a car accident, nearly lost their hand, and after only 2 months, looks like most of the scar had disappeared. This is a boy in Denmark, 9 years old. The fingertip was severed off. They surgically reattached it. After 2 months, he regained use of the fingertip. This is what some people see after a year of using the product. And here is what we refer to as youth renewal after just 2 months of X39, 93-year-old woman, amazing results. So I want to thank you for your time and taking a look at this new technology. Again, it's been a privilege to have this time with you today. Thank you.
All right. Hello, David. Thank you so much for that presentation. Those photos really speak to that the therapy there. We have a couple questions. I wanted to start off with, if there is no light source, how does applying a patch with wavelength selective reflecting surface to the body result in light being applied to the body?
Well, the device is activated by body heat. So it's body heat in the infrared band. So we don't require an ambient source of light. We don't need an active light source. As long as you're alive and you're producing body heat, then we have a power source. So the active body heat will oscillate the organic crystals that are in the patch, and then this causes a reflection of light in the infrared and the visible wavelength that stimulates the surface of the skin.
Excellent. So we're the power source, is what you're saying.
We're the power source.
Excellent. And the next question is, can you do too much light therapy?
Yes, as a matter of fact, I believe this was originally discovered by NASA, that there's the phenomena of attenuation. So if you stimulate the body for too long of a period of time with light, it will stop responding. So most people are familiar with this. If you have an energy drink like Red Bull or coffee, eventually you're going to stop responding to the caffeine. And the same is true with light therapy. So what we've discovered in our research, more than 80 clinical studies now, is that you do have to have an on-off cycle. So what we found works is that you apply the patch in the morning, you remove it at night, and you use the product for 12 hours, and then you have 12 hours of off. And so over studies that we've conducted for a period of a year, people do not attenuate or accommodate to the stimulation. It still works after a year.
Excellent. Our next question is, does this work on old scars, about 2-year-old scars specifically?
Yes, as a matter of fact, one of the testimonials that we received very early on in the release of this product was from a gentleman that had been in a motorcycle accident 18 years ago. And he had some peripheral nerve damage, which impaired circulation in his thumb. And after 3 months of using the product, he was able to regain the circulation in his thumb, and the nail on the thumb that had died actually regrew. So we have seen that older scars that are many, many years old can still heal.
All right. We have another question of, is there any new evidence that brain cells can regenerate?
I believe so. We are involved in a clinical study right now where we are examining how we can activate stem cells in the brain for healing traumatic brain injuries. And specifically what we saw with this technology is that it's capable of elevating GABA. And what's interesting about that is GABA will elevate BDNF, brain-derived neurotrophic factor, and BDNF is a control mechanism for stem cells in the brain. So we've done 2 clinical studies now. One was a pilot and the other was a double-blind placebo-controlled study with 50 people. And we did find over a six-week period of time that there was a significant improvement in brain function, brain coherence and memory, and general cognition. So this is important because it takes advantage of the neuroplasticity of the brain. So basically, the research that we're conducting today is looking at how we can activate very specific biochemical and pathways in the brain, other than GHKCU, for activating stem cells and basically repairing traumatized tissue.
Excellent. We have time for one last question. Does this work for healing broken bones?
So we don't know the answer to that yet. One of the new studies that we're doing is we found evidence that we could activate or turn on the osteoblasts, and we are seeing evidence that we believe is going to lead to the development of a product using light therapy that will activate the stem cells, turn on the osteoblasts, and reverse osteoporosis. So that's currently a product that's in development. So we believe that the same technique, of course, could be applied to accelerating the healing of broken bones. And in electromedicine, there is a very sound basis for this.
That's great news. Well, we appreciate your time so much, David. We had a great talk with you, and we'll let everyone know that if you have more questions, you can jump into the chat or the Q&A forum and get those questions answered. Hopefully, David can have a little time to jump in there and answer those questions if there was any other ones. Thank you.
Thank you. It's been a pleasure.